Now in this video I'm going to go ahead and do some statistical measures of standalone risk. Now if you ever had a stats class, it should be pretty easy. If not, it may be a little difficult, but follow along. I'm going to use Excel. Excel is a wonderful tool for statistics. I'll try to explain as I'm doing each problem to the best of my ability. And let's go ahead and get started with the first one. If you take a look at your computer screen, you should see I created 3 FICO scores. FICO is a credit score for an individual, and 2 investments, investment A and investment B. And the first thing I want to calculate is the average, or as I refer to it as the mean. And I'm going to call it the mean here in standard deviation because we call it the mean in standard deviation when we're not within a population distribution. So there is no population distribution. That would be the next problem. So let's go ahead and do the average or mean for these 3 FICO scores. And if you go to Excel and go to formulas and more functions and stats, all you have to do is find average, and there it is. And I'm going to grab these 3, which it already has done for me. So you can see I already have the average here, 721 average FICO score for those 3. Now the neat thing about Excel is, as long as they're lined up, I'm going to grab the fill handle here, and I'm going to do these 2 as well. And if we take a look, something interesting has happened. Investment A has an average return of 10%, and investment B has an average return of 10%. So at this point, if we were determining which investment we would pick, we'd be indifferent because both of them would return at 10%. However, if you just eye the data, look at investment A and investment B, you can see that investment A has a larger variance or dispersion from the mean or the average of 10%. And here's a visual picture I drew a moment ago for you. You can see that the red line here would be your 10%. This would be 0. And you can see that this green line would be your distribution, and it's much larger for A than it is B. So we're going to already see that the variance and the standard deviation is going to be greater for investment A, so we will pick investment B, and this is kind of the things we do in finance. So let me go ahead and do the variance. Now the one thing I want to mention here with variance is the variance is not in the same units of the FICO score, the investment A, investment B. It's just a number. So in order to make that number make sense, we have to take its square root, which is the standard deviation. Now I'm going to go ahead and calculate it, and there's a couple. I can use the variance. I can use the variance for a sample here, but I'm going to go ahead and use this variance. This way I can grab each of the value and I can kind of tell you what's going on. Well, I'm going to grab the first FICO score. And what has happened when I grab this first FICO score, what it does is each time it takes the mean or average, subtracts it from it, and then takes raises it to the power of 2, and then it's going to sum them all up, each one of them, and it should give me the score. So yeah, 2,000. So you can see that's a number. It's not in the same units and doesn't make a lot of sense. Now I could have also used the variance for the sample. If I'd have used that, I don't have to input each value. It'll just go the B3 through the B6. So either one would work fine. And there's my variance. Now lastly, let's take the standard deviation. The standard deviation takes the square root of the variance and it puts it to units, the same units here, and that makes a little more sense. And we're going to see, hopefully, that investment B has a much higher standard deviation, which means a greater risk. I'm going to just go ahead and put equals square root, and I'm going to grab this number here and hit return, and there it is, 52. It's in the same units. I'm going to grab these and pull across, and we can see 7% or a 70% and a 5%. So we can see investment B is much less risky than investment A. So we'd pick investment B using means, variances, and standard deviations. Now let's try a probability distribution. Now you can see I'm no longer using I'm using mu and sigma instead of your mean and your standard deviation, because we're within a population. So here's the event. We have 2 investments again, same investments, but now look, I've put in a probability that one of the 3 things is going to happen. It could be a strong economy, a normal economy, or a weak economy. And if you notice, all 3 have to add up to 1 because one of those 3 events will happen. So now what I have to do is I have to add 1 extra component. I have to multiply this by this, and I've already done it for you, so I'll click right here and you can take a look at the cell. So I've taken the 80% and I multiplied by the 30%, and I added it to the the weight of C5 and D5, which is this one here, multiplied by this one, and I get 10%. Now, to make it easy, I'm going to grab the fill handle, and I'm going to pull right across, and you can see it's the same 10%. Now, what we're going to do is that's the mu, because we're within a population. Let's go ahead and do the variance. I've already done the variance for you right here. If you take a look at the variance, to keep it simple for time, how to do the variance is very similar. We take the right here, the average return minus the expected return, so that was the 80% minus the 10%. And I did something, a neat little trick here. If you take a look up here, I put a dollar sign because I didn't want the D7 to change. I didn't want that to change. So by doing it that way, I could grab the fill handle and do all three with using that same D. So I did all three of them. So you can see I did each one of them. D5, here's D5. 10% minus 10% is 0. And a negative 60 minus 10% is a negative 70. Then I squared them. You can see here I just took the previous 70% and squared it. 0 squared is 0. And then here I multiplied by the probability, the extra step. Multiplied by the probability. And then I took then I summed them all up. So now I had my variance, but again, not in the same units. So I take the square root of the variance and I get a 54%. So you can see investment A has a 10% return and a standard deviation of about 54%. Now I went ahead for simplicity and did investment B. Here's the 10% as well. However, I did the variance already. I can do it again. It takes time, and it's 3.9%. So again, we would pick investment B because it has the same return but a much lower sigma because we're within a population. Expected returns are easy. If you look on your screen now, I have 4 companies: Yum, Ford, Eli Lilly, and Johnson & Johnson, and each of their expected returns. These expected returns were probably based upon historic data, and you can see that it looks like Eli Lilly is the highest of the 4 when it comes to expected returns, so it's the highest of the risk of the 4 companies. And to keep it simple, I put 25,000 of each amount, so a total of 100,000, so the weight was easy. So in order to determine the expected return, well, very similar to what we did with the probability distribution here, is I'm going to go ahead and I'm going to multiply the weight, which is the 25%, so it's this one here, and I'm going to multiply that by the return here, hit enter, and now I have to sum them all up, and now I get the expected return of about 10.25%. And that's how we do expected returns within a portfolio. Finally, the book shows something referred to as coefficient of variation. Coefficient of variation is, what if you have an average return like you see in investment A of 12% and an average return of 8%. So by looking at that data, you're going to say, I'm going to pick investment A because that's a better return. But now let's look at standard deviation. Standard deviation is much higher for investment A than it is for investment B, so you kind of have mixed results. So which one would you do? So we kind of have to see what is the return based upon that amount of risk. So how we do this is we take the risk, or the standard deviation, and we divide it by the return, and we kind of get a number. I went ahead and made it a percentage. It gives us a number that says it's kind of a amount of risk, 2.5%. I'm going to grab the fill handle here and compare it to this one. So you can see this is only 1.25. That's 2.5. So there's much more risk involved for here for that amount of return than here. So we would pick investment B.